The heart, one of the most reliable organs in our body. With each beat, it pumps blood through our veins steadily when not under duress, just like clockwork, as you can see for example on an EKG. Have you ever wondered how the heart manages to generate the electrical impulse necessary to activate the heart cells periodically? As you may notice, the heart contractions function in the following fashion. The electrical impulse is generated by the sinusoidal node in the upper left corner of the heart, which is a bundle of about 10,000 neurons firing all at once, thus generating the heartbeat. From there, it activates the rest of the tissue as it propagates. Now you can see an arrhythmia, in which case neurons are firing in different groups each as they please, thus resulting in a loss of order, which can have fatal consequences. The same principle applies in the case of the light show that Malaysian dragonflies produce. Imagine all of them lightening up together, and the rest, whom are out of phase, are trying to adjust to the periodical lightning of the majority. Among the tendencies that coordinate nature, there is one that is capable of forging order out of chaos. Take, for example, as you saw in the previous recordings, a gathering of individual systems that are linked together, each operating at first with their own pace, later functioning in one common pace in order. This phenomenon is called synchronization. Synchronization is a phenomenon that occurs with living organisms as well as with inanimate objects that perform some sort of periodical action tuned according to each other. For simplicity, we will call such an object an oscillator. So we've got an oscillator that oscillates at a given frequency, and we've got a bunch of oscillators which will oscillate with different frequencies. Synchronization emerges when these oscillators, after self-adjusting, will oscillate with the same frequency. The first person to observe this phenomenon was Christian Huygens, who noticed that two nearby wall watches with pendulums oscillate after a long while with the same frequency. He realized that that was impossible because there cannot be two exactly identical watches, thus they cannot have two exactly identical frequencies. There needs to be a discrepancy between the periods. He hypothesized for this to be possible that there needs to be a connection between the watches. The criteria for sync to emerge lies within the connection of the oscillators. If there is no connection at all between them, sync will never emerge. So, for two or maybe more oscillators to synchronize, they need to connect with each other. Take for instance an oscillator being a person swinging periodically. If two persons are not connected, they can hardly synchronize their movements. Now imagine the connection being a stick that they hold while swinging. This way they can easily synchronize and swing all at once. Thus, the secret of emerging sync lies within the type and quality of the connection. A simple example of synchronization is the sync of water bubbles. At first, the tube connecting the two bottles is filled with water, which is a weak connection because the bottles can hardly communicate. There is no synchronization. After emptying the tube, sync emerges instantly because air is a strong connection and the bottles can communicate. Thus, the weaker the connection, the harder is for the system to synchronize. The second example for sync is the synchronization of metronomes. These are connected globally, which means that all the metronomes are in connection with each other. The connection is provided by a moving plate on which they are placed. Every metronome gives a small push to the plate. In return, the plate pushes the metronomes back. This way, they can adjust their frequencies according to each other. The result is synchrony. Listen to the claps. The third example for sync is the synchronization of candlelight. These are connected locally, which means each flame interacts only with its neighbors. This connection is realized by the surrounding heat emanating from the flame. and its strength drops with the distance between the flames.